Hi everybody, this video is going to cover graphs of rational functions. You have the handout. On the handout, the first box in the handout deals with a warm-up. We are not going to cover that in this video. So we are starting here with graphs of rational functions. That is the title of these notes as well. So the most basic rational function is the parent function is y equals 1 over x. That graph of y equals 1 over x is listed here. Think back to what we know about denominators and domain and things like excluded values. And so now what I want you to do is I want you to think about what are some things that you notice on this graph and what are things that you wonder on this graph. And doing this on the video, I just want you to write some things down, and when I get back to class, we can go over some of people's observations. If you need to pause the video here to write down a couple of notices and wonders, then pause it here. Okay, on the next box, we have a different graph. When you compare this graph compared to the other graph, there are some differences. And so think about what those differences are. And again, what do you notice on this graph? What do you wonder on this graph? Write down a couple things, and when I get back to class, we will discuss them. But I want everyone to write down at least one or two things under the notices and under the wonders so we can have a discussion when I do return. The fourth box on this page has actually the same exact graph. I believe this graph is the same graph as you saw a second ago on the previous screen. It's just we have some more information here. So here's our graph. Here is our function. So if one of your wonders was, I wonder what the equation is, well, here you go. This is the equation. When we look at this graph, we do know how to do some things. We know how to look for the horizontal asymptote and the vertical asymptote. So the horizontal asymptote is where things get closer and closer and closer, but they don't ever land there. And the vertical asymptote, same thing. It's just going vertically, what you get closer and closer and closer to, but you never get there. And so those asymptotes are actually part of the graph. Like if this was something that we were graphing, we would graph it as a dotted line. And so I don't know if you can see my dotted line, but I did my best there. We would graph it as part of the graph, even though it's not actually part of the graph. So the horizontal asymptote has an equation. A horizontal asymptote is going this way, and the equation is always y equals, in this case it's y equals 0. Vertical asymptote, similar thing. It has an equation. The equation is x equals 0. There's also a hole. Did you notice the hole in the graph? That is, I think, one of the most intriguing parts about this unit is the holes. So there is a hole. It does have coordinates. The coordinates of this hole are 2 and negative 2.5. And that negative 2.5 is not an approximation. I actually know where the hole is, and that is the coordinates of the actual hole. I'm going to clean some of this up so we can see it better. Okay, x-intercepts. Well, we said a minute ago that it has a vertical asymptote. And if it has a vertical asymptote, it has a horizontal asymptote. Well, it has both. But if it has a horizontal asymptote, there are not going to be any x-intercepts. It will never hit the x-axis. So there are none there. Y-intercept, same logic. There is a vertical asymptote. If there's a vertical asymptote, there is no y-intercept. Increasing intervals, decreasing intervals, and end behavior. We have referred to some of these concepts quite a bit, actually, and we probably need to really zero in on these a little bit more in this unit. So there is on your paper, on the back side of your paper, there are 3 slides in there, but there's one box that is left over. Can you turn over to the back? We're going to use that empty space to add this information. Okay, what I want you to add is 2 little graphs. We can title this box increasing and decreasing intervals. On the first graph, I have a parabola, and I might go ahead and list the vertex so that you can, if we all have the same drawing, it'll help talk about that as we talk about it. So this has a vertex of 3, 2. On the cubic, it has a max at negative 3, 4. It has a min at 0, 1. All right, take a minute to write that down. If you need to pause it here, go ahead and pause it. The next thing I'm going to talk about are increasing and decreasing intervals. So what I'm going to do, I'm going to use this as sort of my slider. As I look at a graph, I always start on the left and I go to the right, just like you read. When you read, you start on the left and you go to the right. That's also how we read a graph. So I'm going to start on the left and I'm going to go to the right. Another thing to keep in mind is this is our x-axis, of course, and the x is the arrow over here. That arrow means it could go to negative infinity. And the arrow over here means it goes to positive infinity. So we want to keep that in mind. So the increasing intervals is where is the graph going up? Okay, the left hand, we always start on the negative infinity. As we go from negative infinity over, it's going down. It's not going up, it's going down. Then we get to this point right in the middle, and now it turns around and it starts going up. At the turnaround point, it is not going down, it is not going up, it's neither. Like if an ant was standing on that dot right there, that ant would be flat. Okay, so the increasing interval is from here all the way to positive infinity. So the increasing interval is from 3 to positive infinity. And I put a parenthesis on that because, like I said a minute ago, if an ant was standing on it, it would not be, it would not be up or down, it would just be flat. So the increasing interval is where it is going up, and it's going up from 3 to infinity. The decreasing interval is where is it going down, and it's going down all the way over here from negative infinity, all the way until we get to 3. So that's where it's going down, from negative infinity all the way to 3. When we talk about increasing and decreasing intervals, we always use the x values. So it's kind of confusing because we're talking about up and down, but to describe the up and down, of course, we're talking about the left and right. And so that is, it's just a little bit, some people have a hard time with that, but that's what's going on. So we're talking about the up and down, but we describe it going left and right. This time, we look at the graph. There are actually multiple places where it's going up and or down. So we have to look and see which one's which. Okay, we always start on the left. Starting on the left, going over, it's going up, 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 until it gets here. Well, where's here? Here is negative 3. So we're going to say this is increasing from negative infinity to negative 3. And then I'm going to use this union symbol because there's one more place where it is increasing. And I bet I have to erase my thing again. So there's one more place where it is increasing. The other place where it's increasing is from here, from 0 all the way to positive infinity on the x's. So once again, I think I'm going to take a second to remind us that the x goes to negative infinity and this x goes to positive infinity. And I also see I left off by 1 again, 0, 1 goes there. So it is increasing. It's increasing from negative infinity all the way over negative 3. It's also increasing from 0 all the way to infinity. So it's also increasing from 0 to infinity. And again, those are x values. Where is it decreasing? Let's look at that next. It is decreasing from negative 3 to 0. Just that one little place. That's the only place it's ever decreasing. All right, so it's decreasing from the negative 3 to 0. And so we say it's decreasing as an interval from negative 3 to 0. Once again, we use the x values. Where it's going up, left to right, it's increasing. And where it's going down, left to right, it's decreasing, and we use our x values. All right, let's go back where we were to slot to that previous page. Okay, so we were here, we were talking about some of the characteristics. We mentioned what their asymptotes are, we mentioned where the hole is. All right, our increasing intervals. As we look at increasing intervals, we look at where is the graph going up, anywhere it's going up. Okay, this graph is going up here, and it's going up here. Looking for decreasing intervals is where is it going down? There is nowhere that this graph is going down. If you look at it from left to right, there is nowhere that it's going down. It is always going up. However, there is a gap. Remember, we had an asymptote here. So there is a gap. So it is increasing, and there's going to be a couple of different intervals here. So we want to list all of them. It is increasing from negative infinity all the way to 0. And then it picks up again at 0. And now something different happens once again, is it's not going all the way to infinity because it has this hole. And so we have to account for this hole. And so we say it's increasing from negative infinity to 0, and then from 0 to 2, because it has that hole there at 2. And then it starts up again at 2, and it goes to infinity. Remember that the parentheses on our intervals, the parentheses means it doesn't touch it. Okay, so it doesn't touch the 0, it doesn't touch the 2. Those are increasing intervals. And I know I've written kind of small on this space. You have a very small place to work with. So try to fit this in where you can. But the increasing intervals, that's easy, isn't it? There are none. There's nowhere that it's going down. It's always going up. The end behavior. Most of what we have talked about with end behavior has been positive infinity if it's pointing up, or negative infinity if it's pointing down. Well, guess what? This is not pointing up or down. If we look at the ends of this, it's not pointing up or down. It's getting closer and closer to 0, but never touching it. So this end behavior is not infinity or negative infinity. This end behavior is 0. Okay, let's turn the page. So the previous one, we had the function given to us, and we didn't bother with factoring it because we were just kind of looking at it. Actually, let's just go back to that. I'm sorry, turn the page back to that page here, because let's take a second to factor this out, because really that's why we've been factoring this whole time, is factoring helps us to figure out where stuff is coming from. Like without factoring, it's hard to see some information. Okay, if we factor this, now, let's talk about, okay, where is all of this coming from? Like, where are these numbers coming from? So, for instance, if we look at the vertical asymptotes, look at your denominator. Remember our domain? So if we talk about the domain here, the domain is going to be all real numbers except 0 and 2, right? That's our domain according to this denominator. This denominator gives us the domain, all real numbers except for 0, and all real numbers except for 2. If we look at our graph, we don't have anything at 0. We do not have anything at 2. That's an actual hole. It is a hole in the graph. The graph does not touch it. Domain restriction at 0, we have another domain restriction at 2. If we look at our asymptotes and everything, we have a vertical asymptote at x equals 0. That vertical asymptote at x equals 0 comes from this domain restriction. That's why that does not have anything there, is there's an asymptote because the domain says we can't have anything there. Similar for the hole. The hole is there at 2 because it's here. It's a domain restriction here. And you might be thinking, hopefully you're thinking, well, wait a second, that x minus 2 actually cancels out. Okay, that reason why it canceled out, or the fact that it canceled out, is what makes it a hole and not an asymptote. If it didn't cancel, like the x didn't cancel, it is an asymptote. If it does cancel, like these canceled, then it is just a hole. Okay, intercepts, we talked about there's none there. How about the coordinates of that hole? Well, the 2 obviously came from the coordinate from here. And then, after we cancel things out, if we take that 2 and plug it in, then we would get, so like if we plugged our 2 into here, then we would get negative 5 over 2. Negative 5 over 2 is negative 2.5. That's where that 2.5 came from. Okay, Everything else, I think we're okay on. Again, if you have questions, write them down because when you come to class, you won't remember them. So if you have questions right now, like you don't understand this stuff, write it down so that when you come to class, you can ask those questions. All right. But now let's turn the page to the backside. New function, but similar setup. So if we factored this, factor out the GCF, we'll factor out this GCF. I'm going to call that a -3. All right, and this can be factored even further. So I factor down with a GCF, factor down, the GCF out of here, and then I noticed x minus 4 is a difference of squares, so that's x plus 2, x minus 2, so now I'm left with this. Okay, we think about domain. Our domain is all real numbers except 0 and 2. Same as we had a second ago, I think. That's our domain. We can cancel out that x minus 2, which means if that cancels out, then that's a whole. If it doesn't cancel out, like this -3x is still there, that's where we got our 0 from. That means we're going to have a vertical asymptote at x equals 0. So that's what this asymptote is here. Okay, what else do we have? If we want to go ahead and continue on with that whole, we can continue on with that whole, and we can plug in a 2. If we plug it in, we want to plug it into the canceled out version. So 4 times 2 plus 2 over -3 times 2. That's 4 times 4, which is 16. That's -3 times 2, which is -6. That reduces to -8/3, which is -2.6. So this whole is at 2, -2.6. I'm actually going to call it -8/3. But just so we get like an approximate estimation, like does it actually work there, you can see it does fit there. Okay, another thing is, and I'm going to zoom in on this because again, I know our papers are small and it's hard to see on your paper sometimes. I'm going to erase all of this. If we zoom in here, when we draw things with graphing software, sometimes things will show up, and I actually forgot to talk about that on the previous page, but I can here in just a minute. Some things will show up as like this circle, okay, but this hole, the hole is not filled in, and so that's how we know that is a hole. So this one is a hole because it's not filled in. This one is not a hole. It's just that the graphing software says, oh, this is an important point. It's an x-intercept. And so it graphs it as like a point, but it's not a hole because it's filled in. This one's not filled in. The x-intercepts, we do have some x-intercepts. And our x-intercept is at -2, 0. And there are no other x-intercepts. Take a minute to look at the equation. Where did that -2, 0 come from? Do you know where that -2, 0 came from? Okay, the x-intercept came from the numerator. The numerator gives us our x-intercepts. The denominator gives us our domain. All right, y-intercept, it's not going to have one because it has an asymptote. It has an asymptote. There's no way it can hit that point. It's never going to. Increasing intervals. Once again, there's nowhere it decreases. It's always increasing, but we do have a couple of breaks. So once again, I'm going to go ahead and say increasing intervals are -infinity to 0, union 0 to 2, union 2 to infinity, and the decreasing intervals are none. Our end behavior. End behavior, once again, deals with the ends of the graph. And on the ends of the graph, it's getting closer and closer and closer. Oh boy, what is that point? It's actually -4/3. And I'm going to let you guess and figure out how I knew that was -4/3. Both sides are getting closer and closer and closer to -4/3. It's not going to infinity. It's not going to negative infinity. It's just going to 4/3, -4/3. All right, can you guess where that negative 4/3 came from? Right, it came from the leading coefficients here, negative 4/3. That was my horizontal asymptote. We'll get more into horizontal asymptote tomorrow, so if you don't understand how we got that, that's all right. We can talk about that next time. So that's negative 4/3. I think at this point, the best thing for us to do is to end this video because the video is getting long and do a couple of practice problems from the worksheet. So those two extra boxes that we haven't done yet, we can do those together in class another day. For this video, make sure that if you have questions, you write down your questions and bring them to class so I can answer your questions. It's hard to remember what your questions are when you don't write them down.